Why bloat is still software's biggest vulnerability. A 2024 plea for lean software. Some years ago, this is authored by Bert Hubert, okay, who's a cybersecurity guy. Some years ago, I did a talk at a local university on cybersecurity titled, Cyber and Information Security, Have We All Gone Mad? It's still worth reading today since we have gone quite mad collectively. The way we build and ship software these days is mostly ridiculous, leading to apps using millions of lines of code to open a garage door and other simple programs, importing 1,600 external code libraries, dependencies of unknown provenance. Software security is dire, which is a function both of the quality of the code and the sheer amount of it. Many of us programmers know the current situation is untenable. Many programmers and their management, sadly, haven't ever experienced anything else, and for the rest of us, we rarely get the time to do a better job. What a good summary, what a good opener of the state of the industry. Let me briefly go over the terrible state of software security and then spend some time on why it is so bad. I also mentioned some regulatory and legislative things going on that we might use to make software quality a priority again. Finally, I talk about an actual useful piece of software I wrote as a proof of concept that one can still make minimal and simple yet modern software. Again, another old man, 48, yelling at clouds. At the ripe old age of 41, I can say I do not look forward to being 48. Okay, death gets that much closer. At 48, death kind of stops having coffee with you and then starts having some hard liquor, right? The state of software security is dire. If we only look at the past year, if you ran industry standard software like Ivanti, MoveIt, Outlook, Confluence, Barracuda Email Security Gateway, Citrix NetScaler ADC, and NetScaler Gateway, chances are you got hacked. Even companies with near infinite resources like Apple and Google made trivial, worst practice security mistakes that put their customers in danger. Yet we continue to rely on these products. These pieces of software are considered so dangerous that we tell everyone not to run it themselves. Instead, you're supposed to leave that to an X as a service provider, or perhaps just to the cloud. Compare this to a hypothetical situation where cars are so likely to catch fire that the advice is not to drive a car yourself, but to leave that to professionals who are always accompanied by professional firefighters. Imagine that writing your own front-end code in vanilla JavaScript, HTML, and CSS to handle a simple website is so dangerous, so wrought with issues that instead of doing that, leave it to professionals who have already built a whole bunch of packages for you, third-party packages, and just let them do the work for you. Just npm install away, bro. The assumption is that then the cloud is somehow able to make insecure software trustworthy. Yet in the past, we've learned that Microsoft's email platform was thoroughly hacked, including classified government email, twice. There's also well-founded worries about the security of Azure Cloud and Google Cloud Services, and Amazon has 3 buckets apparently. Meanwhile, industry darling Okta, which provides cloud-based software that enables users to log into various applications, got comprehensively owned. This was before the Daily Tech News, so I didn't cover this. This was their second breach within 2 years. Also, there was a suspicious spat of Okta users subsequently getting hacked. Clearly, we need better software. The European Union has launched 3 pieces of legislation: NIS2, Cyber Resilience Act, and Product Liability Directive. So we'll see how this plays out. Why is it so bad? Making more secure software takes time and is a lot of work, and the current security incidents don't appear to be impacting the bottom line or stock prices. You can speed up time to market by cutting corners. So from an economic standpoint, what we see is entirely predictable. Legislation could be important in changing this. The security of software depends on 2 factors, and this is where AI in particular does large harm: the density of security issues in the source code and the sheer amount of code accessible by hackers. As the US defense community loved to point out in the 80s, quantity has a quality all of its own. The reverse applies to software. The more of it you have, the more risks you run. As a case in point, Apple iPhone users got repeatedly hacked over many years because of the huge attack surface exposed by iMessage. It is possible to send an unsolicited iMessage to an Apple user. The phone will then immediately process that message so it can preview it. The problem is that Apple, in its wisdom, decided that such unsolicited messages needed to support a vast array of image formats, accidentally including PDFs with weird embedded compressed fonts, using an ancient format that effectively included a programming language. So someone could send an unsolicited message to your iPhone that could probe for weaknesses in the rest of your phone. And this way, attackers were able to benefit from security bugs in the phone's millions lines of code. You don't need a high bug density to find an exploitable hole in millions of lines of code. Apple could have prevented this situation by restricting previews to a far smaller range of image formats, or even a single known good image format. Apple could have saved themselves an enormous amount of pain by simply exposing fewer lines of code to their attackers. Incidentally, the EU Cyber Resilience Act explicitly tells vendors to minimize the attack surface. This is an example where the amount of code you create necessarily creates so many different entry points of security issues that would be impossible to detect strictly due to the sheer amount of code. Maybe not impossible, but it would be implausible, let's say that. It would take so much effort. The more code you generate, the more entry points you have. And a lot of these entry points are so minute, so specific, so edge casey that you might not even know that they exist until it's too late. Those who think the biggest problem is the quality of the code expressed in terms of the density of bugs in it are wrong. There are many interesting things happening on this front, like the use of memory-safe languages like Rust mentioned. Other languages are also upping their security game. Fuzzers, test tools that automatically modify inputs to computer programs to find weaknesses and bugs, are also getting more advanced. Many security problems are in the logic underlying the code. For example, the Barracuda email exploit originated in a third-party library, shocker, in Excel spreadsheets when they were scanned for viruses. It would execute code in Excel spreadsheets that were scanned for viruses. Wiping out all the bugs in your code won't save you from the decision to implement a feature to automatically execute code embedded in documents. Another problem is that we often don't know what code we're shipping. Software has become huge. In an article, A Plea for Lean Software, the author described the Oberon operating system, which was only 200 kilobytes, including an editor and a compiler. There are now projects that have more than 200 kilobytes for their configuration files alone. A typical app today is built on Electron.js, a framework that incorporates both Chromium and Node, which provides access to tens of thousands of software packages for JavaScript. I estimate just using Electron.js entails at least 50 million lines of code if you include dependencies, perhaps more. The app, meanwhile, likely pulls in hundreds or thousands of helper packages. Many packages used will also by default snitch on your users to advertisers and other data brokers. Dependencies pull in further dependencies, and exactly what gets included in the build can change on a daily basis, and no one really knows. We have covered this so much on these streams. How many ways to Sunday? If this app controls anything in your house, it will also connect to a software stack over at Amazon, probably also powered by Node, also pulling in many dependencies. But there's more. We used to ship software as the output of a compiler, or perhaps as a bunch of files to be interpreted. Such software then had to be installed and configured to work right. Getting your code packaged to ship like this is a lot of work, but it was good work, since it forced people to think about what was in their package. This software package would then integrate with an operating system with local services based on the configuration. Since the software ran on a different computer than the one it was developed on, people had to know what they were doing. Sometimes it didn't work, which the joke is, well, it works on my system. That's where developers got it from. And then the retort, then back up your email, we're taking your laptop into production. This used to be a joke. But these days, we often ship software as containers, shipping not only the software itself, but also including operating system files to make sure the software runs in a well-known environment. This frequently entails effectively shipping a computer-computer disk image. This vastly expands the amount of code being deployed once again. Note that you can do good things with containers like Docker, but there are a lot of images over 350 megs on the Docker hub. Add it all up, and we're likely looking at over 50 million active lines of code to open a garage door running several operating system images on multiple servers. Now, even if all the included dependencies are golden, are we sure that their security updates are making it to your garage door opener app? No. We've covered this before. We've covered security issues that have been out in the wild, either known or unknown, and unpatched, sometimes for over 10 years. So even if you have a third-party library that does keep their security up to date, knowing that it is up to date or trusting that it can be is extremely low. You actually can't trust it. I've gone over the stats on this. But even worse is the fact that all these dependencies are not golden. The Node.js ecosystem has a comical history of package repositories being taken over, typo squatted, slop squatted now with AI, or resurrected under the same name by someone else with nefarious plans. PyPy has suffered from similar, or PP as I like to call it. Dependencies always need extra scrutiny, but no one can reasonably be expected to check thousands of them. But we prefer not to think about them because it's the cult, easy door mentality that your favorite influencer, that your favorite person on X or social media or whatever, that your colleague, that your manager stresses you to do, or that the executive stresses you to do. No. Take the easy road out because it's more financially reasonable. It's easier on your brain. You're gonna be able to do more stuff with less, yada, yada, yada. All the stupid crap that has been a cancer to the tech industry for the past 10 years. The world is shipping far too much code where we don't even know what we ship, and we aren't looking hard enough at what we do know we ship. Yeah, Elko. SQL injection has been a known vulnerability for decades, and it's still one of the most widespread security issues. Yes, there was, oh man, I was just doing a short on a daily tech news stream the other day. I don't know, episode 13 or something, and it was going over what is the, oh yes, I remember. Yes, healthcare. Too bad Ross isn't. What is the highest security entry point vulnerability of most healthcare hacks in the US? SQL injection. By far. Yeah. And how many times, almost on a daily basis, we go over misconfigured S3 buckets all the time, or Google Cloud Services buckets all the time. This is basic stuff. Security on that is basic. There's even like little buttons you can push to automate that away, and people aren't even doing that. Then the author talks about what they did, and they wrote this thing called Trifecta, and they have 1,600 lines of code, which is about 3 megabytes of code, and they essentially are doing, I believe, an image sharing. It's like IMG-UR replacement. So if you're interested in looking at that, definitely go have a look. It seemed interesting to me, and it gave me a thought. I'm increasingly beginning to believe that there is a whole bunch of money to be made by having programmers who take no investment money. They have no executives, they have no managers, and they don't listen to the stupid bullshit that idiotic tech influencers promote, or package managers, the principles that package managers promote, or the cult-like, they reject the cult-like mentality of all of these things, and they actually care about what they're doing. You can disrupt even currently existing massive websites. And you can do it by writing less code, making it far more performant and far more secure. The issue then comes down to marketing, because a lot of programmers don't know marketing, myself included. And that's where you typically have executives with funding. A lot of funding goes into marketing and ads and all of that. However, marketing is a generally solved problem. And the way to set yourself apart against big competitors who have marketing spend is to provide a free tier, a trial, and just get out there and drop links pretty much everywhere you can. So if you are willing to put in the time and effort, and maybe if you can find a group of other programmers who are willing to work with you on a singular goal to get something done as a replacement for something that exists today that sucks, you can absolutely outdo the big guys, regardless of how much VC funding they have. And really the key thing is sell your strengths. So if you do have a reduced line of code, so for example, let's say that you do what this guy did with Trifecta,